Hello guys, we'll be looking at Program 3 of Data Structures Laboratory. It's about stack and its application, that is the palindrome. So the main function includes the push operation, that is inserting an element to the stack, pop operation, that is deleting an element from the stack, and the palindrome, that is checking if the contents of the stack are a palindrome or not, that is the sequence is read from, if it is read from left to right and right to left, and both of which are equal, then it is called a palindrome. Then you have a display function, then you have an exit function. And coming to case 1 of the switch statement, you have the item to be pushed, it will be stored in the item, and you have the push function call where you'll be passing the stack and the item. Then you have case 2, which is pop. You'll be pushing only the stack here, because pop is nothing but you're removing an element, you're not giving an element to it to be inserted. And palindrome only requires the stack again, and display also requires the stack. So then you have the default, that is invalid choice. Then after which we'll be seeing at the first function, that is the push operation. Push operation is nothing but you are adding an element to the stack. So for that you'll be firstly you'll be needing two header files, that is include stdio.h and include standardlibrary.h. After which you'll be declaring the stack size, that is stack of with a macro function call, that is define max 4. This is the size of the stack. Then you have int stack of max, that is the size, that is 4. Then you have item, then you have top equals to -1. Top equals to -1 is the condition in which the stack is empty. Then you have status, a variable which is initialized to 0. Then you have ret, that is the return variable you're popping out from the item will be popping out from the stack. So firstly it is about void push function, that is you'll be giving the stack and the element. You'll be first checking the condition if top equals to max -1. Suppose if given max equals to 4 and 4 minus 1, that is top is pointing to 3, then we say that the stack is overflow. That means that the elements are full and the top is pointing here, somewhere here. So it is 0, 1, 2 and 3. So somewhere at 3 where the stack is full, it will be pointing. So if not, if it is like that, you'll be printing stack overflow. If not, you'll be going with the stack insertion, that is you'll be incrementing top first. So top equals to -1 will be incremented to -1 plus 1 will be 0. So you'll be incrementing the top value by 1, which will give you 0. So that will be pointing somewhere here, and you'll be inserting the item here. So whatever is there in item will be pushed into stack of plus top. Then you have to increment the status. Why we are using the status will be knowing in the later functions. So you'll be incrementing the status, after which you'll be calling the pop function, where pop is nothing but you're removing an element from the stack and you're printing it. And you have to, for pop function, you have to first remove the element that is present on the top of the stack. The top works on the principle of LIFO, that is last in first out. So whatever is on the top of the stack will be deleted first. So you'll be checking, first of all you'll be initializing a variable called ret. Then you'll be checking the condition if stack is empty. See, if the stack is empty, you can't be popping out any variable. So you'll be checking the condition that if stack is empty, that is top equals to -1. If it is then equal to top equals to -1, then stack underflow, that is you can't be popping out an element if there are no elements in the stack. Then coming to else part, you'll be the stack, whatever is there in the top of the stack will be sent to a variable called ret, and you'll be decrementing the top, because here you're performing the pop operation. So you have to decrement the top value, and you have to firstly you have to give whatever is there in the top of the stack to the ret variable. Then after which you'll be decrementing it, the top variable, to 1 less than that, so that it will be pointing to the next item in the stack. Then you'll be decrementing status here. There will be you'll be incrementing status, here you will be decrementing status. After which printf, the popped element is %d, which will be stored in ret, will be printed. Since we are using int here, you have a return type called ret, where you have the element that is popped here. So this is about the pop function. Coming to palindrome function is 1 to 1. If you read from this side, or if you read from this side, it is the same. So this is a palindrome. Suppose you had an extra 1 year, it is not a palindrome. So this is about it. So palindrome will be sending the stack again, and will be initializing variable I, temp, count equals to 0, and you will be initializing a variable called j to the top of the stack. So it will be pointing somewhere here. Top. If top equals to 3 here, then it will be pointing j equals to 3. So then you'll be whatever is there in status will be put into a variable called temp. So status will be having the count of the elements that is being pushed into the stack. After which you'll be running a for loop for I equals to 0, I less than temp, I plus plus. That is what temp is nothing but the status value. That is how much ever elements have been pushed into the stack. So it goes like this: if stack of I equals to stack of j. So the condition will be like, it will be checking from this side, stack of I to stack of j, because j is pointing to top. So it will be checking from this the upper one and to the lower one. If they are equal, you will be incrementing the top value, then you will be decrementing j. Why decrementing j? Because you have to see the next element. So you'll be decrementing j, and here it will be I plus plus, so I will also be incremented. So you'll check the condition again, stack of I here and stack of j here. If they are equal, you increment count and you will decrement j, and I again it will be increment. This is the for loop that will be running. So at the end of the for loop, you'll be deciding if it is a palindrome or not. For that, what you have to do is you have initialized the temp with the status. So the temp will be equal to, if temp equals to count, so count will be incremented as long as they have the same sequence. So if they are equal, then it is a palindrome, otherwise it is not a palindrome. So this is about the palindrome function. Then we have the last function, that is the display function. So in display function, you'll be sending only the stack. So after you've sent the stack, firstly you'll be initializing a variable called I, then you'll be checking if top equals to -1. That is, if stack is empty. That is, this condition is stack is empty, top equals to -1. If not, if it is that, you'll be printing this stack is empty. If not, you'll be going to the else loop, where you have you'll be printing stack contains R. Then you'll be going with the a for loop where I is given with the top value. So here, and I is greater than or equal to 0. So whatever is here is 0. So whatever is there from here to here will be printed. As we have initialized I with top, you have to decrement top. Then you'll be printing whatever is there in stack of I. So %d stack of I. Then printf. Printf is simply like to go to the next line. So this is about the display function. So this is about the stack and stack application program. Thank you.